All right. Hi, everyone. So I'm Jack McCracken. I work at Shopify, and today we're going to talk a little bit about how we manage security in one of the largest Rails apps in the world. So first off, a little bit about me. They took this photo with a little bit of a low-resolution camera, so, you know, I'm sorry about that. But I love puzzles. I love crosswords. I'm big into baking. These are just two kind of things that I get my mind off software with, and most importantly, I love security. I love making sure that every single one of Shopify's merchants is secure and does not need to worry about their platform security and just gets to do what makes them awesome. So first off, what is Shopify? So Shopify is like a multi-channel e-commerce platform, which is super fancy words for whenever you want to sell something, Shopify will let you sell it wherever. So if your customers are on Instagram, we sell on Instagram. If your customers are on Facebook, we sell on Facebook. Okay, so a little bit of context on what we're dealing with here. So Shopify, the main application, deploys about 40 changes to production per day in 2017. And it has we had 1,900 employees. We had 375,000 merchants and 80,000 peak requests per second. So the joke at Shopify is that we double every year, but I'm going to show you that it slightly outpaced that. So this year, this is a year and a half after that presentation, we deploy 150 changes to the core product. We have 4,000 employees, 1,500 of which are solely in R&D, 800,000 merchants, and 170,000 peak requests per second. So what that means to me is that our two main customer bases as a security team, the employees, the people who need to deploy safe changes, and the merchants, the people who need to use those safe changes, have both doubled or tripled in the past year and a half. So that kind of leaves me feeling a little bit like this. I'm freaked out. I joined in 2017 when those numbers earlier were accurate. And at that point, I was like, oh my God, there's like 1,000 people working on this product. How the heck can 10 people secure this thing? How can we make sure that every merchant that uses Shopify has a good experience and doesn't feel like we're insecure or experience, God forbid, any data breach problems? So how do we prioritize these things? It turns out it's just straight up impossible for 10 people to police the actions of 1,000 people. It's just not a thing you can do. So you need to build it into your culture. You need to make sure that every single developer at your company is aware that their changes impact 800,000 merchants or 1 million users or however many people use your application, that these are real people. You need to make sure that those things are embedded in your culture, and you need to make sure that they don't forget those things. So other thing we do is we use robots, a lot of robots, hopefully better robots than these robots. I like to break down what we do into these 3 categories. So the first one here is make things safe by default. If something looks right, it should be right. If something looks like it's going to be secure, it should be secure. If something looks scary, it should be scary. Second thing, make messing up not the end of the world. Nobody wants to be that developer who's stuck there being shamed by some asshole security guy like, oh, you messed up. And that just doesn't make anyone want to improve. It makes people want to quit. And last, make security cool. Nobody wants to have, again, that security guy yelling at them. People want security in their products. People care about the product, so why not enable them to make their product secure? So first thing, safe by default. Like I mentioned, the point here is to make sure that if someone is doing something, it is safe. And if it is obvious, it's safe, and if it's not, then it's probably weird. So how do you keep things safe by default? You could set up one of those fancy Brakeman CI things that everybody talks about. Brakeman is a great tool, but you need an amazing, big security team to make sure that those changes are relevant to your developers, or they will start ignoring them. We had this experience. you need to keep it simple. Make sure that the changes you're making that add process are not necessarily things that impede your developers from doing their job. The first thing I'm going to talk about is the little example of one of the vulnerabilities that we run into on a pretty regular basis. I'm sure most of you are familiar with cross-site scripting, but we're going to talk about it just for a little bit here. So you can see here, pretty standard ERB template. It has a insertion of the parameter name, and it has this weird method HTML safe called on it. So what happens if we go and visit this site? We go to good.com/whatever, name Jack. Get hello Jack. That's exactly what you'd expect. The interesting thing comes from if you try to pass JavaScript in here. So if you do a script alert document.cookie here, you'll see all the cookies. And every time I do one of these, every time I show somebody one of these alerts, they're like, oh my god, another security person popping up an alert box and telling me it's the end of the world. I like to describe this in the sense that anybody who sends you this link and you click on it could do anything you can do in that application. So with Shopify, you could add a product, you could change the password, you could do anything. And as an attacker, that's a really, really juicy target. So how do we make sure that as a large company, we're not a target for that kind of thing? So when you put that into the DOM, you actually see that you get hello and then a literal script tag, alert, and script tag. And that means that you are allowing whoever is inserting code into your, or inserting text into your website, you're allowing them to execute code. The problem here is that HTML safe. So if we take that out, we get this. It looks like hello and then a bunch of symbols. You can see the LT, so that means that insert a literal less than sign, and then the GT, which means insert a literal greater than sign. And this is actually going to show you something like this. Weird name, but still better than a cross-site scripting vulnerability. All right, so HTML safe. What the hell is this thing? I started in security. I had no experience a year and a half ago, and I thought that what this did was mark the string as like escaped. It escaped the string, and it like took out all the bad stuff, and if you call HTML safe on it, you're good to put it into an ERB template. Turns out, it does the exact opposite. This is a very bad name. It's not safe at all. So, what it actually does is it takes a string and turns it into this thing called a safe buffer, and a safe buffer inserted into an ERB template will not get escaped at all. So you won't get that LT thing. You'll get it inserted in literal HTML. So what we've done, this is going to be mind-blowing, is we enabled a cop. So Rubocops are amazing here. There's a bunch of them already built in Rubocop for Rails. This one is specifically called Rails/output safety. And its job is to literally look for any usage of HTML safe and raw, which is basically the same thing, in your code, and just flag them. The problem here, though, is what if you really meant HTML safe? What if, let's say, you're rendering Markdown, and you're sure that whatever came out of here is safe? Okay, so how do you handle that? What we've done to give people a way to do that while blacklisting all the HTML safes in our code is we've given this method a much more appropriate name in our code base. Dangerously output as HTML, because it's dangerous. It's not safe. So the other thing we've built is we built this thing called Caution Tape Bot. So Caution Tape Bot is not an invention of our team, but we co-opted it to effectively just whenever there's an HTML safe in a PR, it just goes and says, hey, we're not sure that you might be using an HTML safe. Maybe you should read our documentation on that. Maybe it's not a great idea. And then our team comes along and reviews. All it does, tag somebody for a review and comment on a PR. You could implement this in probably 15 minutes with a GitHub action. You've got GitHub webhook coming in, check it against the regex, shove out a comment and a review request. Not hard, keeping it simple. So you can see here the effectiveness of that. I've done a little bit of redacting for the person's name, but you can see that there was some code with .html safe on it. Our team member mentioned, hey, there's no HTML here. Why don't you just not use HTML safe? And then the person responded with, oh, I copy-pasted it, my bad. And the HTML safe was gone, and lo, another thing was removed from our code base. Another thing that we've built that I really like is this ERB lint application, or ERB lint gem. What it does is it's a little smarter, because we talked about how inserting to HTML, you pretty much get this handled for you by Rails. Rails will just escape anything that is passed in via those like less than, %, equals. We'll just get escaped as HTML. Interestingly, though, if you do the same thing in JavaScript, that is not the case. So you can see here that this onClick listener is actually inside this onClick listener is JavaScript, and then it does alert of some data. So if you were to do exactly this, a single quote would not be escaped. And you're allowing somebody to do arbitrary JavaScript execution on your own code base, on your own website. So it's not always safe. But if you install ERBlint, you'll get a Rubocop warning for the top one saying, hey, this is a JavaScript context. You should add 2 JSON to there so that it doesn't necessarily allow you to escape out of that context. And it will give you a check mark or do nothing if you're in the second case. All right, so you can actually get that here. I've just included the link. These slides will be on Twitter, so don't feel like you have to write them down or anything. This gem, quick win. It also has some cool runtime checks that will make sure that your code doesn't necessarily, if it is vulnerable to cross-site scripting, it'll do some basic sanity testing on input to make sure that it's safe. Obviously, that's not perfect. We can't solve cross-site scripting for you, but this will both stop people from putting cross-site scripting into your app, and it will allow you to just like deal with it when it happens in production. So the second problem we're going to talk about today is cross-site request forgery. So cross-site request forgery happens when an attacker is able to execute an action on behalf of a user without their knowledge by making them visit another site. So let's say here we have this form, and it's on everyone's favorite website, good.com. So good.com has an account system. It lets you specify an account. You can edit, let's say, your username, your password, your email, everything in here. And this is what the form looks like. You actually see this token here. We'll talk about that in a little bit. But if I were to take that, and instead of doing it on the website, set up evil.com, which then calls good.com/account/your account ID, I can just change your name and password if you visit my site, which is not ideal. So how does Rails handle this? So by default, as is going to be a running theme, Rails handles this for you. The problem is there's a bunch of legitimate use cases where people either need to tweak or completely turn off these settings. The setting actually allows you to just, you see that token in the previous form here? It just, it checks whether that session token is equal to the token in the form, and if it is not, then it does not allow the request to happen. That's the standard behavior of Rails. But if you turn it off, like our good friend here on good.com has done, using skip before action verify authenticity token, that request will work, and your password will become hunter2, and no one wants that. So this skip before action is another bad pattern that we've noticed, and there's almost always a good way around it, similar to HTML safe. So you should use this most of the time, protect from forgery with exception, unless your server is talking to other servers. If you're talking to clients, protect from forgery with exception is the safest option, 100% almost all the time. What we've done is similar. We built another caution tape bot rule, which uses a regex looking for skip before action, verify authenticity token, and it sends a message saying, hey, maybe you shouldn't. Here's the cases in which you would use X. Here's the cases in which you would use Y. Here's the awesome Rails documentation on this subject. And it requests from our forgery protection enforcers group. So the second thing I wanted to talk about, my second theme from earlier in my slides, was messing up should not be the end of the world. I think somebody has a really good way of saying this that I couldn't even come close to doing, so I'm just going to put it up. We don't make mistakes. We make happy accidents. In security, a little less true, but what we can do is turn the mistakes into happy accidents. So we can take these things, have a positive outlook on them, and like I was saying before, not get mad at the person who did the thing, but get mad at the process. Get mad at the things that allowed them to get there. Because obviously this is a failure of a system if it's happening in your code base, not a failure of an individual, most of the time. So what we've done is we've built a couple safeguards that allow people to notice when they've messed up and quickly and effectively address it with little to no data exposure. So this is a very common pattern you'll find in a Rails app. You'll see a controller. That controller will have an action. That action will then do a find with some parameter, and that parameter will then be user-controlled. So the problem here is that if the blog were to, let's say, belong to a user, that blog would not necessarily be belonging to that user, right? So if I went here and let's say I'm user number 5, and I look at blog post number 8, and blog post number 8 doesn't belong to me, and then I try to edit blog post number 8, that shouldn't work, right? You don't want anybody being able to edit anybody's blogs. That's just a recipe for disaster. So how do you handle this? This is the control. So here's what you would look like, what this would look like in a regular app, what you would look like if you were using vanilla Rails. And we've built a gem that allows you to simply add firewalled to the start of that. And what that'll do is it will make it so that your user object is checked every time that you go and you make a request that involves that user object in a belongs to relationship. It will check the belongs to, check the current user using the new 5.2 current attributes feature, and then it will actually just for 500 if the data does not belong to the current user. So you get an error like this. Rather than being able to edit someone else's blog post, you get told, oh, something went wrong, and then the developers somewhere in the background are like, oh, we got an error. Maybe we should fix this. So some people might say this should be a 403, which is unauthorized, but I think that these things should be solved at a higher level and handled a little bit more gracefully by the involving application, and this should just be kind of a safety blanket for if there's a security problem. So how that would look, handling at the higher level in the application, would be using your current class and going current.user.blogs.find. We call this, the vulnerability that we just solved, an insecure direct object reference. So what that means is you're trying to reference an object via its ID, and it is insecure because you're not providing access control on it. You can find this gem open sourced a couple months ago at Shopify/Active Record Firewall. I recommend you install it in your applications. Soon it will even have a report-only mode so that you can just set this mode onto your app and you'll get logs instead of blowing up every time that you see one of these unauthorized accesses. And you'll actually notice that if you install this on your app and add those firewall belongs to, your test suite quality will increase significantly. We found that in our core application, 300 or 400 tests were failing just because they didn't have the control of like, oh, well, we're accessing shop A and then we're using shop B's data, and that would blow up because this gem would be like, oh, that's a security problem, and they made our test suite much more consistent and much more like accurate with the real world. So the next thing we're going to talk about is this thing we built internally called Watchtower. Again, this isn't open source, but it's not rocket science. This thing literally just goes through a big list of domains that you provide to it. It looks for GraphQL, it looks for Sidekick, and it looks for graphical. These three apps we've found have a commonality of being almost always exposed. If you go to most Rails apps or most unmaintained Rails apps that aren't the core product of a company, you'll find that some of the time their Sidekick will be exposed under /Sidekick because it's hard. The Rails code to make these things secure and put them behind authentication is not pretty. And that's the problem. That's safe by default. That's not safe by default. So how the heck do you check all these things? A lot of companies have a problem even with knowing what the heck services exist. So if you run this app, or if you just run a script, I wrote a bash script that did this, it just goes and hits every single one of them, checks for a 200, sees a 200, it's like, oh, this is a problem, sees a 404, that's fine. That means that the application either doesn't have one or that it's not telling you it has one. If you see a 301, you're probably getting redirected to authentication. All gravy. So, the last thing. These things fail. These we can't make a security-proof sandbox for this application because it does so many things. it's just impossible to actually like make it completely secure. So how do you handle that? What we've done is we've set up a bug bounty program. So what these are, I'm sure most of you are familiar, but it's a way for hackers or researchers to get monetary incentives for hacking on a company. So what this does is gets good guys on your side when the bad guys are already trying. I guarantee you there's already bad guys looking at your app. So, should you run out and implement one of these for your company right now? Maybe. The only problem is you need a mature security team and you need somebody who is able to handle these reports kind of on a full-time basis. The thing we recommend if you don't have those resources, and a lot of these things can be implemented by those teams, is just setting up a security@yourdomain.com email and having a page explaining your policy on security. So if you have a page, there's people out there who can help you with this. If you have a page that just says, we won't sue you for hacking on our website, there's a lot of people who will come along and be like, hey, I found this cool vulnerability for free. So I'm going to talk briefly about 2 vulnerabilities from our bug bounty program. So this first one here is the most paid out bug bounty on the Shopify program. And it was a server-side request forgery, which is just convincing a server to make requests on behalf of you and doing something nasty with that. So what this person was able to do was he used the Exchange app, which is something we built internally, which allows you to sell your Shopify store to another interested entrepreneur. And it let you just take a screenshot of your store, and it'll put the screenshot onto your listing page. Pretty like normal behavior, right? It turns out under the hood this used a headless browser, and so the combination of that headless browser and the fact that anybody can customize their Shopify store to contain anything resulted in the fact that you could redirect to this really old, obscure Google Kubernetes API and just get access to our Kubernetes cluster. The cool thing here, though, is that we were able to get this vulnerability in from a hacker. He gave us an amazing detailed report, which I'll link to on Twitter later, and that report probably saved us millions of dollars. We only paid $25,000. So we were able to figure out nobody exploited this thing, great, and then we gave the hacker a reward. So the second one I'm going to talk about, you don't have to read these diagrams, by the way. I know they're like super long. It's basically just to give you an idea of how complicated these vulnerabilities are. The second one allowed you to pretend you had confirmed an email when you had not, which doesn't sound too bad, but it actually ended up allowing a user to log into any Shopify store. Again, what the heck? This is crazy. So we ended up paying out a decent amount of money for this one, but we probably saved a lot of money, and we were able to mitigate both these vulnerabilities in less than an hour. This one on Christmas Eve, nonetheless. Good Christmas gift. So the thing to take away from here is that these bug bounty programs and vulnerability disclosure programs allow you to find vulnerabilities that are just impossible to find if you are using static analysis, if you're using any of the tools I mentioned before. These are just things. This thing, I think I looked at the number of PRs that were involved in creating this monstrosity of a vulnerability, and I think there were 3 separate PRs that actually culminated via like weird circumstances, and like the fact that if you did 20 requests at the same time that were doing different things, you could convince the server that you were confirmed when you were not. So the last thing we're going to hit on is probably, in my opinion, the most important. As I mentioned, it's just impossible. If you've got a team of 10 working to secure the changes of 1,500 developers, that's just not scalable. People need to be invested, and people at Shopify are. Every developer at Shopify knows that their changes are responsible for the livelihoods of 800,000 individual businesses. And that is a big responsibility. So how do we make sure that people are up to date on the latest security and make sure that it's not their full-time job? Because it is mine. So how do we make this fun? Everybody wants to be like this guy. That's been my experience, at least, is everybody wants to be a hacker. So if you show them how to be a hacker, that sounds a lot cooler than security training, doesn't it? So we don't call our workshops mandatory security training. Heck, they're not even mandatory. We call them learn to hack. So people come out to these things in droves. We have had 300 Shopify employees attend these things. And all we do is we show a vulnerability in an app. So for example, this is what we call a SQL injection. I haven't hit on them in this app, in this presentation, but this allowed you to get all the products here. And we set up this little simulation of Shopify. We built it over 3 days. And it just lets you try out these vulnerabilities. We demo to you one of them, and then you demo us another one after looking for a little bit. And we give out prizes to the people who demo. This is incredibly effective, and you don't need to build a Shopify clone or whatever the hell your app is called, clone, to do this. You can use something that's already built. So Google made this thing. I'm not going to try and pronounce the name. I'm not even going to go there. Guire. But basically what its job is to be the most vulnerable application on the web. If you Google this name that I can't pronounce, and you go to their website, you can click a button, and you will get an instance of this app running on Google Cloud. You don't even have to have it running locally. So what it'll let you do, test out a bunch of vulnerabilities. Google has documented this incredibly well, and the source code is available, if I remember correctly, so you can go and look at the source code and see how to fix it. The other thing, specifically for this crowd, for Rails people, is OWASP has built this thing called RailsGoat. And RailsGoat, its job is to be the most vulnerable Rails app in the world. It has every Rails vulnerability you could think of under the sun. So RailsGoat, I would recommend just setting this up, having your employees hack at it. Even if you're just a security-conscious developer at your company, book a couple people, just even post in your developer channel and be like, hey, let's take an hour together to work on this vulnerable web app and see how much we can tear it apart. I bet you can find some really good ones really fast. So, another thing, we were like, oh my god, these hacking workshops are great. How do we level up this security awareness training? We decided that we would set up this thing called a Halloween Hackfest. We basically worked together to make a spooky CTF. And what this CTF, or Capture the Flag competition, was about was finding these little things called flags. They're little text strings. They start and end with a curly brace, and you can hack an app in all kinds of various ways to get these flags, and then those flags get you points. We were able to have, I think, about 30 Shopify people attend this free beer, free candy event where we talked a little bit about a security program, and we had about 50 challenges set up. A team managed to solve all 60 of our challenges in a 3-hour period. And they weren't even from security. These guys had attended our workshops and they had learned these things. So that was a great feeling. The even better feeling was when someone hacked our damn leaderboard. So what happened was we had not HTML safe, but we used Action Cable. And we had not escaped the input we were putting into the live updating scoreboard. So someone hacked our scoreboard. Shows you that literally everybody can have this happen to them. So, the second thing we built after deciding, hey, that was super awesome, was we built this thing called the Shopify CTF, or Hacking Challenge. This thing is basically the same as the Hackfest, but it runs all year round, and it will have prizes, it has all those kind of good things, and people have been engaging so much. We've had over 50 signups, heading towards 100. And those people have all been working in their spare time, getting a coffee, whatever. They get to spend 15 minutes learning about security. And now we've started building changes about vulnerabilities that happened in Shopify. So if you are able to build something like this, where you just take, let's say, the latest Rails vulnerability, spin up a little Rails app, run it on 5.2, and then shove it on the internet, there you go. CTF challenge for the new Action View vulnerability. So, last thing. I have some takeaways for you guys. These are things that we've found are the most important parts of running a security program, or at least an application security program. Great security tooling does not parent. Great security tooling, if you're going to build any, and you should, make sure that the developer is safe while treating them like an adult. These people care, as I've said a couple times, they care about the people who are using your product, or they wouldn't be there. They care and they want it to be secure, so help them. Don't baby them. The second thing, The only way to scale security is if you're going to automate it. There's no way that your security people, or even the number of security, like super conscious developers at your company, is going to scale to the point where it's equal to the number of developers at your company. Hiring 1,500 security people to deal with 1,500 developers is silly, because developers care, as I said. The third thing is, make people want to learn security. So if you package it up like I was talking about as some dry security guy standing at a podium telling you about security, guilty, then no one's going to learn it, right? No one's going to want to listen to you. People are going to be checking their watches like, how the hell do I get out of here? Whereas if you treat them like adults and you show them, hey, these are the vulnerabilities that have happened in your own application, then you'll get people's attention. And the last thing is, security is everybody's responsibility. If you're working on a product, take a second to read up on these kind of things. Take a second to learn about the most recent Rails vulnerabilities, all those kind of good things, and that kind of stuff will multiply times over. Thanks so much for listening. Since this is a sponsored talk, we're hiring. Shopify has positions in application security and a bunch of other security-related fields, along with a crap ton of Rails developer positions. So if you're interested in something, we probably do it at Shopify. Feel free to DM me or talk to me outside if you have any questions. Or you can just put your hand up now. We have 10 minutes, so screw it. All right, thanks.